All right, today we're talking about multiplying fractions. Essential question, how is multiplying fractions different from the process of adding fractions? So think about that. So our example, humans sleep about a third of each day. If a year is made up of 365 and a fourth days, determine the number of days in a year the average human sleeps. So we start with finding a third of 365 and a fourth. Now a good idea is to always try to estimate before you start any kind of word problem. Try to think ahead of time. What do you think a reasonable answer might be? So what I did here is I first estimated a third of 360. I just went ahead and rounded down to 360. Do you know why I rounded to 360? Well, it's because 360, that's easily divisible by 3. So it's 120. About 120 days is what my final answer should be. And let's find out how to really find the true answer. So again, I know that the answer should be near 120, so I'll be thinking about that in the back of my head as I do the problem. But in order to actually solve it, first I need to convert 365 and a fourth into an improper fraction. I do that here. Now, at this point, there's a couple of things you could do. You could do some cross-canceling and try to get 3 out of here. I didn't do that. I went ahead and just multiplied across. So 1461 times 1 and 3 times 4 on the bottom. So when I'm multiplying, I just multiply straight across. Numerator with numerator, denominator with denominator. Next, I then reduced. So I said, let me see if 12 can go into both of these things. So I go ahead and divide by 12 and find out what I get. If I divide by 12, 12 doesn't go in here evenly, but I do find out it's 121.75, which I know 0.75 turns into 3/4 as a fraction. We talked about that in earlier sections. So therefore, I'm going to check my answer to my estimate. 121 and 3/4 of a year, or days I should say, compared to 120. And sure enough, it's really close. So I know that I'm probably reasonable that the answer is there. So the average human sleeps 121 and 3/4 a day, days per year. So it's a lot of days that we end up sleeping. Here's your key concept. To multiply fractions, multiply the numerators and multiply the denominators. Easy enough. My favorite type of fractions is multiplying. It's pretty straightforward. Just go straight across and then reduce when possible. Okay, look at this example. 1/2 times a third. So I just multiply the numerators together and the denominators together. 1/6, and then I can't reduce, so I leave it alone. Let's take a look at another example. How about this one? One's not a fraction as it is. Well, first thing I want to do is convert 2 into a fraction. That's pretty easy. Just write it as 2 over 1. And then the same thing applies. Multiply the numerators and the denominators separately. If I do that, that's what I get, -6/4, which is -3/2, which can also be written as -1.5. I'm okay with you just leaving it as an improper fraction, but know how to change it to a mixed number if necessary. Here's another example. All right. Numerator with numerator, denominator with denominator, just multiply straight across, and you end up with that answer. Reduce when possible. So a couple ways you could do it. You could, at this point, take a look and do some canceling. You could divide out a 2 from both the 2 and the 8, which I did here. And you get your answer here, -3/28. Other way you could have done it, you could just multiply straight across. That would be -6/56, and then reduce, divide by 2, and get this answer down here as well. A couple ways you can do that. Here we go again, 2/3 times -4. So first change -4 to -4/1. Multiply straight across. At this point, I can't really do some cross-canceling. There's nothing that we have similar factors in common, so we just multiply across and then change it to either an improper fraction or a mixed number as necessary. Here's some final examples. Method 1. So we're going to talk about 2 different methods. This one you can rename the mixed number. So let's take a look what that looks like. So notice 4 and 2/5. I can convert that to 22/5, make it an improper fraction. Okay, at this point, I'm going to multiply across the 1 and 22 and the 2 and the 5, but I go ahead and divide 2 and 22 by the GCF, which is 2. It's what they have in common. They have a 2 in common. I can make this a little easier for myself. It makes it 1 times 11 and 1 times 5. Multiply straight across and then change to a mixed number if necessary. Now watch the second example. Same problem, except this time I'm going to use some mental math. And this is a good idea to start thinking about this process. Okay, so 4 and 2/5 is the same as 4 plus 2/5. So I basically broke them apart. Okay, so 1/2 of this, of 4 and 2/5, is really half of the 4 and half of 2/5. So I use the distributive property. Well, what's half of 4? Well, half of 4 is 2. What's half of 2/5? Well, that's 1/5. Put those back together, and there you go, 2 and 1/5, which is the same answer as I came up with over here. Now I ask a question. Well, if I'm taking a look at this process, why was this method so effective in this problem? Would it have worked with a problem like this? Would I have wanted to use it like that? You tell me. Think about that. That's it for notes today.